No matter how complicated the motion, there's a point called the center of mass. We can't see it, but it follows this nice, smooth path. That happens to be my son Christian. He's a dentist, and in 3 weeks he graduates as an orthodontist. I'm going out to his graduation. And here he's doing a little flip, and my son-in-law caught it on camera. And I submitted this picture to my publisher. I have a textbook, and I wanted to put that on the cover of the 7th edition. My publisher called me up and said, hey, really? I mean, that's a really funny-looking kid. And I said, yeah, but he's my funny-looking kid. And the guy said, yeah, but he's still funny-looking. And so they ended up putting a picture that was similar in many ways, but with a very handsome, athletic guy that was not funny-looking. And he's a nice kid. He's a nice kid. Now, to find the center of mass, it's just like finding the average of your grades, your grade point average. Now, I hacked into the Canadian higher ed system, and I found the transcript for my friend Jeff Adams, and you can see that he's really good at physics, not so good at other things. But he's got an A, he's got some C's, and so I would estimate that he's got a GPA of, what do you think, B? Yeah, that's not the way we do it. What we got to do is we have to recognize that physics is more important than calculus. You knew that in your heart, right? I mean, it's 4 credits and calculus is only 3 credits. So what we have to do is we have to take each grade and we have to weight it by how many credits that grade represents. And if we do that, then Jeff Adams' grade point average is a 42, which seems high, but it's Canadian, right? It's inflated. No, we've got to divide by the weighting factors, the credits. And if we do that, we find that his GPA is a 2.5. Now, in truth, Jeff Adams just always got A's in everything. He's one of the most brilliant people I know. But I know someone who hasn't, and that's me. I got accepted to MIT because I had really, really good grades. I was the big fish in a small pond at my university. There weren't very many physics majors. And I got to MIT and I found that every nation in the world sends their geekiest students to MIT. I mean, it was the center of geekdom. And I found that I was behind. I did not measure up to these geeks. Now, in your graduate courses, everyone pretty much gets an A or a B. You know, the top half of the class gets an A, the bottom half gets a B. And that first semester, I got straight Bs. I was the dumb kid in the class. And my dad called up. He was so excited that I had gone to MIT. He was so proud. He goes, Greg, how did it go? I got a 4.0. That's wonderful. That's wonderful. I knew you could do it. I knew you could. I forgot to tell my father that MIT is on a 5-point scale. Yeah, I feel bad. But that's the way it was. So the second semester, I got things figured out. I got caught up, and I started doing well. And I got straight A's the second semester. My dad called up, how did you do? He said, straight A's. Same as last time. Silence. He still doesn't know. He thinks I got A's all the way through MIT. It didn't happen. Now, in a system, if we want to talk about the center of mass, it's usually pretty straightforward. If I have something like a beam that's made out of uniform density wood, then the center of mass is going to be, well, in the center. And if I want to quantify that, I set up a coordinate system called 0, the left end. And in that case, my center of mass would be located at 2 meters in that coordinate system. Now, if I added something, that's going to move the center of mass. Your gut tells you it's going to move to the right. But how far? Well, we need to do a weighted average. we take the center of mass of the being, which is right at 2 meters, and we weight that by how important it is to the system. It represents 50 kilograms. We then add to that the center of mass of the box, and we have to weight that by how important it is to the system. It's 25 kilograms. And then we divide by the weighting factors, the kilograms, and what we get is the new center of mass would be at 2.33. Now, for a more complicated system that had more than 2 objects, we would just extend that formula, just adding up all of the center of masses times their masses, and then divide by the weighting factors.